Bismillahirrahmanirrahim. Assalamu alaikum students. I'm Sabir Hasnan, your science subject teacher from grade 8. Today is our first video after the first term exams, and we will start a new chapter, electricity and energy. If you remember, in first chapter we discussed about work and energy. Over there we said energy is basically the ability of a body to do work, and the unit of energy is joules. Later on we discussed about different forms of energy: mechanical energy, over there kinetic energy and potential energy, gravitational potential energy, elastic potential energy, chemical energy, nuclear energy, etc. So, and light energy as well. Later on we discussed about the conversion of energy as well. Over there, if you remember, we discussed about different examples of energy conversions. For example, we discussed about microphone. In microphone, sound energy is converted into electrical energy, and similarly we discussed hair dryer, where electrical energy is converted into thermal energy, and we related this to the energy conservation law, or in other words we call it law of conservation of energy. Over there we discussed energy can neither be created nor destroyed. It is converted from one form to another form. Straightforward, very straightforward. It means we cannot create energy by any means, and we cannot destroy energy by any means. It is just converted from one form to another form. There are number of examples. For a few examples are given below. For example, television sets and car are useful examples because they carry out energy conversions. If you look at television, the example of television, over there electricity is used to switch on the television. It means, and we will get the light energy and sound energy because the picture gives us the picture on television screen, okay, and as well as the sound coming from that television. It means that television converts electrical energy into sound energy, light energy, and there is energy loss, and that energy loss is in the form of heat, okay, because the temperature, if you touch the screen or if you touch the back side of your television, the temperature of the television is bit higher, that is a bit hot, so it means there is some heat loss in television as well. So come toward the second example, where car converts chemical energy into mechanical energy, sound energy and heat energy. Look, we use petrol in a car, and that petrol has chemical energy, and due to that chemical energy, that is converted into mechanical energy. Mechanical energy means a kinetic energy, because that car move, or you can, another word you can say movement energy as well, okay, and along with that there is a sound and heat as well, which is actually the lost in this case. Let's move towards the new concept related to energy, and that new concept is basically called Senki diagrams. Okay, look at the diagram. Through this diagram we can easily state or define the Senki diagram. So it is a simple way of showing energy conversion, and where energy goes, that is to draw in the form of arrows. Okay, so this diagram actually looks like a set of arrows. And look at the figure. This figure is one example of a light bulb, and in this light bulb, look, this is the electrical energy. So light bulb uses electrical energy, and look where this energy goes. It is converted into, most of the energy is converted into the light energy, and remaining amount of energy is converted into the heat energy, which is actually in the form of loss. So this energy is lost in the form of heat energy. So keep in mind, Senki diagram actually is in the form of set of arrows, and it tells us about the energy conversions and the losses as well. Now let's discuss few diagrams related to different energy sources other than the light energy. So this figure tells us about the motor. So look at the left side of this diagram. Electrical energy from motor. It means motor use electrical energy, and this energy is converted into the kinetic energy. Here we are discussing car. You can say motor, water motor at your home as well. So if you consider this example for water motor, so that water motor at your home also uses electrical energy, and that converted into the kinetic energy as well, because that motor starts rotating. Along with that, it produces sound and as well as the heat. So this sound and the heat is actually the loss of energy in this case. So this is the energy arrow or the Senki diagram for electric motor. Now look at the next example. In next example we have two figures. The left side, on the left side we have lamp, and on the right side, that is Senki diagram for the bell, electric bell. So you know lamp, definitely that converts electrical energy. So here on we have electrical energy, and most of the energy is converted into the light, and remaining amount of energy is converted into heat. And on the right side, which is the diagram related to the bell, and you know electric bell produces sound, so this sound is the main energy which is produced through electrical energy. And here is the movement of a bell, because the vibrations in a bell produce sound, and you know sound is produced due to the vibration. So this movement is actually the loss of energy in this case, I mean in case of electric bell. So the homework for you in this case is you have to draw the Senki diagram for a buzzer which is given in your book, and that is homework. Keep in mind, in buzzer that produces sound energy and the heat energy in the form of heat loss. So you have to draw a Senki diagram for the buzzer, which is your homework. Let's move towards the one important point, which is the efficiency of the source which we used to produce different things by using electrical energy. Come again at the previous figure in Senki diagram. Look, here we have 100 joules of energy. Out of 100 joules, 75 joules of energy is converted into the light energy and 25 joule is in the form of heat loss. So it means the efficiency is 75 joules. If we use 100 joules and here we have 80 joules, it means out of 100 we have 80% the efficiency. So the amount actually used, which converts the electrical energy into other form of the energy, is that efficiency is related to the efficiency of that specific substance, that specific device. So here in case of light bulb, that energy is converted into electrical energy is converted into light energy, so it has efficiency 75%. So efficiency, keep in mind, the percentage of efficiency actually tells us about the conversion of energy into that specific form. So I hope you learned a lot from this video. In next video lecture we will discuss about power supplies and voltage sources. Thank you very much. Take good care of yourself.